the previous videos, we have been mentioning about the graduate attributes. There are 11 graduate attributes. These include engineering knowledge, problem analysis, design or development of solutions, investigations, tool usage, the engineer and the world, ethics, individual and collaborative teamwork, communication, project management and finance, and also lifelong learning. We mentioned that you should look into the definitions, read between the lines. You will see every single components to be the essential part of those graduate attributes. Ultimately, if we are able to produce graduates complying with all the requirements and the components, we are really producing good engineers. There is no doubt that the engineer graduate produced will have the ability to compete in the global markets. Remember, we mentioned about the Washington Accords. It is a mutual recognition among the signatory countries. We are putting ourselves at the international platform to compete with the graduate engineers coming from different countries. Therefore, we will need to produce graduates on par to their standards. When you read through the graduate attributes, you will see a lot of WKs. For example, WK1 to WK4, WK5, WK8, WK2, WK6, WK1, 5, 7, WK9, and WK8. What are those actually? These are the knowledge and the attitude profile, being coded as WK. W here are meant for Washington Accord. We mentioned briefly about the WK when we talk about the graduate attributes. In these videos, we're going to discuss in detail about the knowledge and attitude profile, WK. There are 9 WK in total. The definitions are outlined here. How do we use this knowledge and attitude profile? In the program, there are various courses being offered. We can look into the courses to observe the content and the expectations of the courses for us to decide the knowledge and the attitude profiles. You need to bear in mind that your mindset should not be reframed by the course. Of course, when we talk about certain engineering discipline, there are some compulsory courses. But what is behind those courses are the knowledge and the attitudes which you wish to deliver to your students. Upon completion of your program, they will be the graduates. It is not the course that the graduate carries. It is the knowledge and the attitude that you have implanted within the graduates. So the ultimate goal here is to make sure the relevant knowledge and attitudes are really in place within the curriculum, not being too much governed or controlled by the course. The mindset needs to be slightly different. We are looking into the knowledge and the attitude profile. Another way to interpret this is that when you look into the graduate attributes, they never mention anything about any courses being offered under the engineering program. They always put the emphasis on the knowledge and attitude profile. On this basis, theoretically, if you are offering an engineering program, not in the mode of compilations of the traditional courses that constitute the engineering program in certain specific discipline, theoretically, this should also be working. It doesn't compromise the graduate attributes. As long as you make sure all the elements are achieved, and all the relevant knowledge profile are effectively delivered. Even though the curriculum is not designed to be in accordance to the traditional manner, the program should also be recognized under the Washington Accord. This is something that you need to bear in mind, that which I believe many lecturers do not even consider about this. Why is this important? Because we do not like the design of a program is being limited by any existing program which has been traditionally accepted in the past that shall ultimately reframe the performance of the program. The traditional or existing program can serve as a guide, but those shall not reframe and limit your design in your program. This is in line with the applications of the graduate attributes, which has been clearly stated in the IEA document. Quote, "The requirements are stated without reference to the design of program that will achieve the requirements." What does this mean? It means that the requirements in terms of the graduate attributes, as referred by the requirement here, these graduate attributes are defined based on what is expected from a graduate of the engineering program. It is not based on the references of any existing programs. They are looking into the fundamentals of engineering graduates instead of any existing products of engineering. Now, if you understand the concept behind all this, your program design can be very creative. You can maximize the applications of outcome-based educations, release the reframed by the traditional perceptions in terms of the engineering program. You can actually design really good program, specific, effective, and highly optimized. Now it will be very much dependent on your courage, as well as the awareness of the fellow academicians in the academic field. Personally, I feel that the mentality and the understandings of this IEA are rather advanced. There is still a huge gap between the typical academicians in our academic field from the full interpretations and understanding in terms of the methods as recognized by IEA. We are still very much reframed by the traditional models of engineering programs, which I do not foresee in the near future that can be easily breakthrough, at least among the fellow academicians within my circles. Anyway, get back to the knowledge and attitude profile. The main point here is we want to design a program solely based on the graduate attributes, where within the graduate attributes there are knowledge and attitude profiles specified. Those knowledge and attitude profile will have to be incorporated in the course of actions in order to achieve the intended graduate attributes. Now let us look at the knowledge and the attitude profiles. WK1, quote, "A systematic theory-based understanding of the natural science applicable to the discipline and awareness of relevant social science." You will need to read between the lines here. The emphasis is still with the natural science. What are the natural science? We are talking about physical science, physics, chemistry, and others. Now the emphasis is on the natural science, but when you apply those, you should have the awareness of the relevant social science. That means the social science can also be part and parcel of the theory-based understanding and knowledge. Now, what are the social science? We are talking about the economics, sociologies, and etc. This has been implied here and there, such as in WA6, talking about the society, economy. Those are a part of the social science. And it happens that WA6 has the knowledge profile of WK1. The things here is in line. Next is about the WK2. This is about conceptually based mathematics, numerical analysis, data analysis, statistics, and formal aspects of computers and information science to support details analysis and modeling applications to the discipline. They make it open-ended here to the discipline. That means there will be relevant mathematics, numerical analysis, data analysis, statistics related to different disciplines of engineering, such as civil engineering, mechanical engineering, and electrical engineering. They are looking into the nature of the knowledge. You can make a general classifications under the mathematics, computing, and information science. WK3 is related to engineering fundamentals, a systematic theory-based formulations of engineering fundamentals required in the engineering discipline. This one will be very much dependent on the disciplines of the engineering. Taking civil engineering, for instance, we are talking about engineering mechanics, statics, dynamic, theory of structure, strength of materials, structural analysis, and so on and so forth. This may also include the fluid mechanics, soil mechanics, and etc. These engineering fundamentals will be essential to establish the first principles related to the engineering discipline before venturing into the specialized knowledge, which the specialized knowledge it will be under the WK4. This is about the engineering specialist knowledge that provide theoretical frameworks and body of knowledge of the aspect practice areas in the engineering discipline. Much is at the forefront of the discipline. That means this one is related to highly specialized knowledge, which is at the forefront of the discipline. It is very ahead at the tip of the emergence of the technologies. Next, it will be the WK5. It is about the knowledge, including the efficient resource use, environmental impacts, whole life costs, reuse of resources, net zero carbon, and similar concepts that supports the engineering design and operations in practice areas. They make it generic under different disciplines, and they also leave it open-ended, not only outlining the aspects that you need to consider. It also involves those with similar concepts. And this kind of knowledge will need to support the engineering design and operations. Next, it will be WK6. Knowledge of engineering practice. They put it in the bracket, technology, in the practice area in the engineering discipline. Now the technology here can be in the modes of tools, system, operations, process, equipments, and etc. As long as those things are related to engineering practice. WK7 is about the knowledge of the role of engineering in society and identify issues in engineering practice in the discipline such as the professional responsibility of an engineer to the public safety and sustainable development. When you see the term sustainable development, you know that they're always going to be related to the Sustainable Development Goal. Now, WK7 is related to the knowledge of the role of engineering, their responsibility to the society, particularly in terms of the public safety and the sustainable development. Next, it will be WK8. Engagement with selected knowledge in the current research literature of the discipline. Awareness of the power of critical thinking and creative approaches to evaluate emerging issues. This is about doing research and investigations. Not only that, there will be elements of critical thinkings and creativities. And the relevant knowledge and skills will have to be adopted and applied in evaluating the emerging issues. This gives us an idea that engineering is not talking about the things which has been past only. Also, it is not on the current only. It also involves what is coming in the future. It has a broader perspectives. For the things that have passed, as long as you have the awareness, take initiative to analyze it, you will learn from the past experience. For the things which is current, it requires efforts to study and to know what it is. As for the things that it is in the future, you will need to analyze and forecast. All this require critical thinking skills. And when it comes to the solving the problem at the current and at the futures, this is where the creativity comes in. Next is about the WK9. It is about the ethics, inclusive behaviors and conduct, knowledge of professional ethics, responsibility, and norms of engineering practice. Awareness of the needs of diversity by reasons of ethnicity, gender, age, physical ability, and etc., with mutual understanding and respect, and of inclusive attitude. This is all about ethics and inclusive attitudes. There shouldn't be any segregations or discriminations. The responsibility will be the same across the board, and engineers should perform professionally throughout. It is stated in the document that a typical engineering program will have a duration of 4 to 5 years. Any program less than 4 years is likely not being recognized under the Washington Accord. If you want to save time, you can design the program by 4 years. You can have more years for the program. It takes longer time for the students to graduate. This will slightly make the program less attractive, especially for the students registering the engineering program. Some non-engineering programs can complete their bachelor degree in 3 years or 3.5 years. Now, if you design your program to be 5 years, there will be comparison among the stakeholders. Since it is already stated here, you can do the program in 4 to 5 years, and it is achievable in 4 years, as long as the curriculum is properly designed. You may also consider from another perspective, because ultimately the graduates are to be discharged into the industry. If you are able to produce really good engineers, and you really need that durations of 5 years, why not? You build up your good reputations, and the industry is demanding for the graduates produced by your program. So whether it is 4 years or 5 years, it will be very much dependent on your preference. You might need to strike a balance between the qualities of the graduate produced as well as the attractiveness of your program to be enrolled by the potential students.